While we are on the topic of order reduction, I would like to give you another exercise. I just want you not to freak out. I'm going to write the differential equation. Just don't freak out. It's going to be pretty easy. Uh, so the differential equation looks like this. The second derivative of f equals minus square root of 1 plus first derivative of f to the power 2. Okay. It looks as ugly as it could be, but well, that's what it is, and it's going to be easy. I will give you a hint how to solve it. Let's say this the function is defined on x starting from 0 going to 1 over 2, and let's say f at 0 is equal to 0, and the first derivative of f at the other end, 1 over 2, is also equal to 0. Okay, pretty cool. Okay, we're going to do order reduction for this guy. So how do we do that? See, I would say I have second derivative and I can reduce this differential equation to a first order differential equation. See how I do it. I'll say I have another function z, which is equal to first derivative of f. Okay. Now I'm going to plug this into the differential equation up there. So I will end up with z prime on the left hand side. That's the first derivative of z is second derivative of f. I'm just replacing here. Is equal to minus square root of 1 plus, and the first derivative of f, I set it to z to equal to z, so I'll have 1 plus z to the power 2. Alright, awesome. So now let me do another thing. Let me just take this square root and put it in the denominator here on the left hand side. So z prime divided by square root of 1 plus z to the power 2 is equal to minus 1. Right? I don't know if I helped or not, but I did. I honestly helped a lot. So let's say this is now the differential equation that you want to solve. And it is pretty straightforward because you can actually, it's just like the first differential equation that we solved, exactly the first one, because the left hand side is actually a derivative of a function. The right hand side is also a derivative of, well, minus x. So if you take the indefinite integral of right hand side, you will have minus x. If you take the indefinite integral of the left hand side, you will end up with a function. Let me write out the function that you're seeking for. So you gotta solve this. And the left hand side, if I take the integral of the left hand side divided by 1 plus z to the power 2 square root of everything, I can't write it here, let me write it right below, is equal to sine hyperbolic inverse of z. Okay, that's pretty awesome. So if you take the integral of this guy, you will end up with sine hyperbolic. So go ahead and do it for this fellow. Take the indefinite integral from both hand sides. You will have inverse of sine hyperbolic left hand side and minus x on the right hand side. Don't forget the constant. And so what you will end up with is essentially a function that you have to solve with for z. So your first task is to solve this guy. Solve this fellow for z. And then when you found z, use this guy that we said z equals f prime. Solve this guy, and you will end up with a family of solutions. And when you had f, go ahead and apply the boundary conditions here. And well, you'll find the solution. Find the solution just as always. Find the solution and plot it And that would be all. I think you can do it yourself. It's pretty straightforward. There's not much you need to know, but that's basically the gist of it. So let's review what you got to do. What we did here. Uh, we had this differential equation, the ugly one. We reduced the order this way. We've introduced another function such that it's equal to the first derivative of the function we're looking for. We inserted this new function z into the differential equation to find a new differential equation. We just changed the order in here. We just took this square root to the denominator on the left hand side so that we have a familiar term. This familiar term is actually, I told you guys that if you take the integral of that, well, you will end up with inverse of sine hyperbolic. And that was it. The rest of it is up to you to do. And that was exercise number 7. Okay, have fun with it.